Hello and welcome back to the SHA1 Performance Quest episode 3. The last episode we have left realizing that the borrow checker is telling us that our design basically sucks and we have to adjust it to make it similar to the one of SHA-256. That means our state needs to be put into a separate struct that can process itself. Let's get to work. It's rather easy to implement a SHA1 state. It has 5 U32 members that represent the state and the final SHA that is returned. It can be created using new and it has a process blocks function. For now, 20 times fast forwards is what we want to do here. Here's something interesting, something less related to Rust, more related to programming errors. Here's me, the old me, basically thinking, whoa, somebody's going to access this struct and it's private by default, right? So you have to make it pub. Yeah, let's make it pub. Well, no. I think the rule here is that you can access structs which are, or private members of structs which are within your module, which is kind of cool, I think. And even though I'm not quite sure, I have to look it up, but at least I can tell you in the aftermath, it does work if the pub is not there, so don't do that. Back at the output method, it became clear to me that we have to pay especially attention to detail here. The detail being that whenever we call our function, we have to return the same exact value. On the left side, SHA-256, this is dealt with by basically preventing any additional work and just having a finished variable to keep track of whether we are finished or not. Whereas in the current SHA1 implementation, it will just redo the work over and over. Fortunately, we can be sure that this will work if it worked once, just because we do not modify our state. We are immutable in that function, that method call. So there's no way we can possibly mess our state up and then produce an invalid result. However, better safe than sorry. This is why I decided to put in a unit test, or basically alter the test so that I at least call this function multiple times, this method multiple times, to verify what's happening. Sure, initially I'm kind of confused because I couldn't really understand why there is a deref, and it first dereferences a pointer and then gets the address again just to be able to compare it to whatever is returned, to the string slice that is returned by the iteration. I didn't really get that, but maybe I will understand it one day. I should be able to understand that one day and know what pointers are, and I dealt with that before, but right now I am confused. Old me is confused and current me is as confused still. Finally, we have arrived. The write method in the hasher, that's the one where it all happens, and there we are feeding the chunks, and that's where the borrow checker last time told us that we can't do it. But now, with the SHA1 state separated into its own struct, we should be, well, we have the same design basically as SHA-256, where everything works just fine. So, yeah, I'm very curious to see how that works out for us. Just a few minutes later, everything seems to be fixed and I'm back in the output method, which should do something now, but not again. The borrow checker hits us, strikes us, stabs us in the back, cannot move out of borrowed content, cannot move out of M because it is borrowed. I mean, one thing I must say, this compiler, sometimes it speaks to you like a person, it knows better about that stuff than you will ever do, and I love it. If I say that the borrow checker hits me again, I actually am glad that it does work totally fine and can actually tell me about it. So yeah, some borrowing that has to be fixed. I suppose it must be something with the local variables that we have, and well, a little birdie tells me that I don't get the scope thing right away because reasons. So first, let's try the drop, right? Drop only invocates or works on things that have a destructor, which is not the case here. So why do I do it? Because I've read it or I've seen it somewhere and out of context, I thought, well, worth a try. Second thing I learned is use scopes. So if something hits you further down, maybe put some mutables out of scope right away. So this is what I'm doing here, hoping that it will now like what I did, and quite. And it's the buffer again. Do you remember the last time we dealt with the buffer? I think it was in episode 2. Let me recap that. And indeed, the clones strike back. Or don't they? Well, that very much depends. I mean, last time I tried the clone path, it didn't really work out for me because that wasn't necessary. After all, I just want a simple copy, you know, like you copy an integer or copy a float. That's what I want for that thing. So how do I express myself in Rust to get that to work? Let's ask Google one more time. But this time I actually asked for the right thing. And there we go. You know, I've not been there last time. Why is the copy trait needed for default array initialization or something? I mean, whatever, copy trait. Look at that. So I have to implement the copy trait for my type in order to get that to work. And that's how it looks like. All right, I will do that, no problem. You know, if that works, I will definitely, you know, I say this to myself, remember, value or copy by value works if you implement this trait, and you have to do it, and there's no derive thing to get it automated or something. No, you have to do it yourself. And look at that, it actually works. Amazing. Well, let's define works, right? Let's just ignore the SHA-related errors down there and move up to the warnings, which are much more convenient for me right now. You know, one step after the other. So, something, use, deprecated. Okay, so, in short, the slice calls I do there are deprecated, and now we have to do the slice notation, which is fair enough, you know, it's good. Let's remember that. Also makes your code more, more concise, shorter, maybe. I will try that and will just work myself through that list. It's worth stopping by to look at this little gem that I encountered during the conversion process. So there is type mismatch resolving as iterator and does not compute error. I mean, in my head primarily, I'm sure the compiler knows what it tries to tell me there, even though I'm not quite sure. I just know that the for loop doesn't get an iterator. It gets this thing there, the mutable index somehow. And, you know, what can I do here? I tried something. So first, let's remove this itemut, right? So maybe it just, you know, it's a slice now. It's a mutable slice. Maybe it just does that automatically. Good. And yeah, maybe we have to do it like that as well and see this works. And after all, this is quite all right. It's explicit, it's readable, it's relatively concise. And just because I had trouble initially converting this doesn't mean it's bad or anything. I think it's just a matter of getting used to and being sure you remember to keep the operator precedence right here and mark it with parentheses accordingly. Okay, now that the warnings are fixed, let's get back to business here. And something seems wrong. The tests fail, and this shard looks suspicious to me. And it might be. There is the remote possibility that I destroyed SHA1. And I have no clue how to fix that. I know where, but I don't know why this even happens. I thought I kind of translated the code correctly. Will SHA1 ever work again? And if it does, will it ever be fast? These and many other questions shall be answered in one of the next episodes. I hope you liked it. If you do, click the like button. Helps me out a lot, and see you next time.